using your straight edge, that's why you got it, go ahead and connect all of those. Alright. And label it at the end just y equals x. And here you can do this in the color pen, or if you have the highlighter, here's where you go over with the highlighter. Everybody do that. And just go ahead and repeat all that. Go ahead on A, B, C, and D. Go ahead and graph y equals x. Now we don't need to do a point everywhere, but just enough so we can graph. So we can do one at 1, 1, 0, 0, and then maybe 9, 9. And then maybe over here, negative 8, negative 8. Just enough points to be able to draw a nice straight line through them all. Now it's interesting, after we get into all this slope, y-intercept, some people have a lot of difficulty with graphing y equals x, because they're like, well, what's the numbers? What's the 1 over the 1? What's the slope? What's the rise of the run? And they lose sight that this just means where the x and the y numbers are the same. That's why it's 1, 1, 2, 2, 3, 3, 4, 4. We don't have to go straight into like this algorithm and do these steps. We can just, maybe more common sense, figure out that, oh yeah, this is a line where all the y's and the x values are the exact same. This is why this is the parent function, because the x and the y's are the same. Okay, go ahead and do that for A, B, C, and D. Okay, highlight it or go over it with a color pen or something like this so it's obvious that this is the parent function. All right. So now what we're going to look at is what happens when we go from a positive x, like this is the black one right here, is the y equals x, to a y equals negative x. You can see that it's reflected over the y-axis. And we want to get used to doing is not having to do a t-chart or a table or anything, but just thinking about this parent function, and that if it's a negative, that just means to flip it over the axis. It's like the exact opposite. Same thing here. If we have a parent function of y equals x, and we see y equals x minus 4, we don't want to have to make a t-chart and a t-table to make this. We want to understand that we can just take our parent function and move it down 4. And that's why it's x minus 4. Okay. So that's the whole purpose of all this, is how to get these graphs without actually plugging in numbers and trying to do it that way. Okay. All right. So you guys have already, this is the first one, you guys have already drawn your parent y equals x. Let me go ahead and get mine on here. And I want double arrows, always double arrows. Okay. Now, what would it look like for y equals 2x? Okay. What's the slope of that line? What's the slope of y equals 2x? Yeah, 2 or 2 over 1. So this is the same as 2 over 1. What's the y-intercept? 0. Yeah, there's no number here, so we just say it's 0. Okay. So here's the old-fashioned way. We'll try it this way first. We'll see which one's faster in the end. This means I want to plug in each of these x values that are on the x-axis. Those are the numbers you plug in, called your domain. And all the answers are going to be up on the vertical, called your range. So this says plug in 2 into here, and what do you get? Plug in this number, 2, what do you get? 2 times 2 is 4. So I'll put a dot at 4. And let's plug in 5. Plug in 5. 2 times 5 is 10. And let's plug in 0. 2 times 0 is 0. Plug in -4. And we get -8. Now, if you do anything wrong, that means that there's a mistake. If you do anything wrong, these will not go in a nice straight line. Okay? That's one way of knowing that something is wrong. Okay, so go ahead and plot that. So we got this one, that is y equals 2x, and our parent graph, just y equals x. We have 2 of those. And it's going to ask you below, what changes, or what's the difference between these two. We'll talk about that in a second. Just fix it. Go back home and fix it. Just make do with it.
Monday, right?
Okay, let's go down. Actually, let's skip down to C. I want to get this going because we're running low on time. Go ahead and graph y equals -x. What does that look like? So what's the slope here? If it's -x, what's that slope? -1, which is the same as -1 over 1. What's the y-intercept? When there is no number here, just use a 0. Good. Yeah, so we want to do this. Let's try this the old-fashioned way and just plug in numbers. So that means we're going to try all these x values and plug it into here. So if we plug in 2, remember this is like a -1. What's -1 times +2? -2. So you go down. Remember the vertical is your answers. So you go down to -2 on the vertical. And then let's plug in, I don't know, -7. What's -7 times 1? Yeah, so we go down here. Just plug in 7, you get -7. Right there. We can also plug in negatives. What happens if you plug in -4? What's -4 times -1? Positive. So you go up to +4. And you can see after you have 3 dots, if they're all lined up, you're probably in good shape. If they're not lined up, one or more are wrong. Let's do another one maybe out here. Plug in -9. What do you get? Yep. So you go way over here. Use your straight edge. and draw a line with 2 arrows on either side. Redraw it. Make it a little bit neater. Good. Now, what do you notice about these two graphs? How are they related? Yep. Well, what can I do to the blue graph, the parent graph, in order to get the red one? Is there a way I can move this around? Right, so I want you to yeah. If I take this blue graph and I flip it or reflect it, you see how it turns into the same graph. Watch this again. I could take my original graph and flip it or reflect it over the y-axis, and it gives me my y equals negative x. So this is how you want to think about graphing, as opposed to always just doing a t-chart. If you have a negative in front, what does that do to the graph? Well, it just reflects it over the y-axis. It's a reflection. Yeah, first we'll do fractions, then we'll do one at a time. All right. Good. So below there it says how are the graphs related or determined? Say down there below. Describe how the graph differs from y equals x. I want you to write for 1c that the y equals negative x is reflected over the y-axis. Is reflected. All right, that's the word you want to be able to use and understand, that it's a reflection. If you have them both on there, you see how they're symmetric down the y-axis, down the middle. There's some symmetry. That's because it's reflected. So big buzzword, reflected. Reflected. And that's when the slope is negative. When the slope is negative, it's reflected. And these are going to be the questions I'm going to ask you. I'm going to ask you, of course, graph this, but I'm going to ask you, how do these two graphs compare? And you'd have to use language like that. Well, it's reflected over the y-axis, and then I'm going to give you another word right now. It's going to be for the y-intercepts. Okay. So right here, just watch up here. Again, I'm going to have my parent graph in blue. That just goes down the middle. Right. Now, what happens if I have x plus 3? How does that differ? Yeah. How is that different from y equals x? What happens when you put this plus 3 at the end? What does the graph do? So let's graph it. Let's do it the old-fashioned way and see how they compare. All right. So let's plug in 4. Plug in 4 to here. What do you get? 7. So we have to go up to 7, positive 7. 4 to 7. And let's pick some other points. How about 0? What do you get when you plug in 0? Yeah, we just get 3. What happens when you plug in negative 3? Yeah, what's negative 3 plus 3? What happens when you plug in negative 8? Negative 5. Okay. Use our straight edge. Look like we got a lot of points. Oh, missed it. A few more. There you go. Now, how does it relate from the blue graph to the red graph? How do they differ? It's parallel. But isn't one, if I could just move one up, can I just move this blue one? I can move it up how much? Yeah, if I just move it up and then it all matches. It all lines up.
So they're all going to be the first graph to be up and
Yeah. So you can see I can move my parent graph up 3, right? Up 3, and it gives me x plus 3. Again, we don't want to always have to look at it as, well, this is a completely different graph from the one I just did. It's really the same graph from y equals x. It's just moved up 3. That's why the plus 3. Now, when we move up and down like this, it's called a translation. Translation. So when you flip with the slope and the positive negative, that was reflection. And when you move up and down, we call that a translation. So you can say that how they differ, you can say that y equals x was translated up by 3. So having this y-intercept, you want to think of it as a translation. It moves it up and it moves it down, up and down the axis. Okay, and you guys have seen this before, right here. That when I move just the y-intercept, it's the same line. It's just the line that's being moved up and down. So when you're asked to graph y equals x plus 6, and when you're asked to graph y equals x minus 8, you shouldn't think like, okay, these are two different problems. It's really y equals x moved up 6, and then y equals x moved down 8. It's the same line just being translated up and down. Okay? So this is one of those things like, if I give you like 10 of these to graph for a quiz, they should be really fast. You shouldn't make t-charts for each one. They should be really quick. Because you're translating and reflecting, not, plug in 2, what do you get? Plug in 5, what do you get? Okay, so that's the big picture on all these. So you want to be able to graph, not by using t-chart and everything. Sometimes you have to do it. Sometimes they're really complicated, and that's fine. But for more basic, we want to understand what's really going on here. We're really just moving around y equals x in many different ways. Okay? Again, reflecting. Reflecting just meant we go over the, reflect it over the y-axis. When we go negative, we just reflect it. Alright, so you guys are going to work on this, and when you're graphing, here's the tough thing though when we're doing this, is that you have to really be thinking about when you see x minus 3, you have to think x minus x, y equals x, and then moving it down 3. I don't want you plugging in numbers, and getting the graph and saying, look, I got the graph right. Because remember, I want to be able to give you a quiz next week where you have 10 of these to do in, maybe 2 minutes. And you don't have time to plug in a number, plug in a number, plug in a number. You have to take y equals x and say, oh, it's just that moved down 3. Oh, it's just this reflected over the x-axis, and graph them rather quickly. Okay? Or when we get to the slopes, oh, this is just twice as steep because it's 2x. Oh, this is half as steep because it's 1/2 x. That's what you get on the front page of number 1. There's a 2x, it's twice as steep as y equals x. Then there's a 1/2 x, that's half as steep. It doesn't go up nearly as fast. Okay? So go ahead and continue working. You want to finish all the graphs by the time you come to class tomorrow. Okay? That's your homework for tonight, to finish all those graphs. You still have a good 10 minutes, so work together and finish all the graphs. Okay? All right.